Hello, my name is Jacob Greenberg, and today we're going to look at CAD software, 3D printing, and how we can take this simple plastic piece that you would use to hold a screen window together from broken to whole again. Stay tuned. Okay, so to start with this, the first thing we're going to do is take our pieces and we're going to start on good old-fashioned paper. So when we put it together and we think about how we're going to make this, we have to look at first how, what are our tools that we have to work with. So when you design in CAD, you have extrudes, you have chamfers, you have other extrude cuts, and this is actually a pretty simple model from the looks of it. So the first thing we're going to do is measure this square here. So I'm going to go ahead and think of this as like a top view. So you look at the top view of it, you have that square, and we're going to take the piece that has the most purchase on it. We're going to go ahead and measure this at 28.5 millimeters. So this is going to be a 28.5 millimeter square. And then for depth, we're going to look at how deep we want our square to be. So we'll go ahead and quickly draw this ISO view to give us our depth. So we want it to be just add these features real quick just so we know where we're at. So for our depth, we'll take it and measure it across the top like that at 7.8, 7.86, about 7.8. So that's going to be 7.8 millimeters. Okay, and now for the tangs, these little tang parts, we're going to have to draw that on this face right here. So I'm going to draw a square that is that face. And we know that the top of it's 28.5, the side of it is 7.8, and now we have the little tang in there, like so. So we'll measure its width, 19.3. Measure the other one just in case, 19.24, 19.24, 19.17, 19.25. So we'll do 19.25, I think. So its dimension right here is 19.25, and its depth, similar to how we did the body itself, 6.84, 6.8, 6.89, 6.86. We'll do 6.8, 6.8, like that. Okay, and then so we have 6.8 there. I'll draw those out so we remember it. 19.25 there, and then this dimension to the end right here, we'll need that as well. So when we think about how this is drawn, these actually aren't symmetric. They're not on the center line of it, they're actually offset slightly. So when we look at it like this, maybe we'll actually sketch these in like so, just so we understand our point of reference. So this here, this is, we'll call this detail A. So this is, looking at that like that, so this is detail A. So we'll know that there's a little cutout right here as well that we'll need to contend with. So let's take a look at that cutout. How far from the edge are we? So we measure it like that. We're about 5 millimeters, I'm going to call it. So this dimension right here is 5. And the dimension from the other side then is about, I want to say, 3.9. So then this dimension here is about 3.9. Let's just go with 4. Okay, so that's that. Now let's look at the length of this tang. So we'll draw it from the top again. And we have this tang here like this, and this tang here like this. So this distance from here to here is going to be about 29, I'd call it. There's a couple different ways you can measure things, so you can do it like that. About 28. So we're going to call that 28 millimeters, like that. And then what else do we need to measure? These chamfers. So these chamfers actually aren't 45 degrees, so we'll do a two-dimensional chamfer. So measure that at roughly 3. So 3. And then right here we'll do at roughly 5. So this is roughly 5. Okay. Alright, so then the last thing we have is, if we take a look at this, there's this channel along the back. Now I'm not going to model every single little facet inside of there. I don't necessarily think it's needed. So the thing I'm going to look at doing is, so we have this one here, so this will be detail B. And then we have this little notch channel, so that'll be detail C. So detail B, let's address that now. So here's our top view again, and we have the notch. So we'll draw it like this. We need those dimensions, and then we also need the depth of cut, because when we go and do this in CAD, we're not going to tell it this distance, we're going to tell it how far down to cut. So we'll denote that as this. So first let's grab our dimensions here by using the plunge side of our caliper, 4.7. Okay, and we'll confirm the other side. It looks like a square, but we want to make sure. And that's 4.7. Okay, so 4.7, 4.7, and the depth is then 6 millimeters. Okay, so we'll call that 6 millimeters. Alright, and I think the last one we have is detail C, so this is detail B, and now we need detail C, and that's that channel. So we'll draw it from a side view again, like this, and it's just going to be a simple cutout like that. We need our depth, need our width, and we need our distance. So I kind of cheated a little bit and already measured this once. I know that these are 1 millimeter each. And this depth here we'll measure again real quick just to make sure. So for that we'll use our plunge again, bring it down. It's about 3.8. 3.8. And then we need to measure how far apart it is open in here. About 5.25. Make that spot. Let's pick another spot. That one's too broken. Let's try this one. 5.75. So we'll do 5.75. Alright, and we'll make all this work out when we go into the 3D model too. We don't have to be perfect. But those are the key dimensions that we need. Now let's go over to CAD. Okay, when we first open Fusion 360, it gives us a new window. So if I just close that, there it is. This is what I have mine set up to look like. And we're going to refer everything back to the drawing that we made. And we still have the parts in the caliper, so we can measure it out if we need additional details. But like I said, we're going to start from the base. So we'll quickly create a rectangle here for the base, and we measured that as 28.5 by 28.5. So there's that. We're going to extrude that the thickness that we measured at 7.8 millimeters. And now we're going to add the tangs. So the first tang is over here. We're going to draw in a rectangle again, and we hit D to dimension. So we need this distance, and that was going to be 5 millimeters, and this kind of scooted out, so we'll drag that over. Don't need the thickness yet, but let's hit D again. Okay, so this one is going to be 4 millimeters. And then what we'll do is the height. So we have here to here. That's going to be 6.8. And then looks like we didn't measure this in our drawing. So I'm going to grab my calipers real quick and grab that distance, which is about 0.5. So we'll go from here to here to be about 0.5. And there we go. So now we go back, we extrude this out to a total of 28 millimeters, and that's done. And then we'll do the same thing to this other part here. And normally I would just pattern these, but for whatever reason they don't pattern very well over the axis, and I think that's just because these dimensions here aren't symmetric. So that's 5. Bring this back inside. Dimension the thickness, I suppose, which was 6.8. Dimension top to bottom. I have to measure it again because I forgot. 0.5. There we go. And then dimension from here to here. That's going to be 4. All right. So now I need to go. We'll extrude it again. Also 28 millimeters. There's our initial part. Let's do some quick checks for symmetry. 0.5, 0.5. Okay, that's good. Next, we'll cut out this little square right here. So to do that, we need a new sketch on that plane. For this one, we're going to project this top surface, so it'll give us the box lines. And we'll draw from here to here. We'll dimension each one at what it is, so 4.7. And this side here, 4.7. Finish sketch. Extrude. So we're cutting. So we're going to go negative 6, I believe. Yeah, there we go. Seems a little bit too shallow. So let's remeasure 6.2. All right. So let's go back on our feature tree here, edit feature, we'll make that minus 6.2. Whatever, that looks fine. All right, so the next thing we need to do is to cut that channel work back here. So let's do another sketch on this surface. And we're gonna draw another rectangle like this. And we're gonna start dimensioning it out. So we have top to bottom being 5.75, and we have this to here being 1, and we're going to do this. It'll over constrain it, which is fine. We just want to balance it, so 1.05, 1.07, so we're going to do 5.8. There we go. And 3.8 deep, so we'll dimension again from here to here, 3.8. I believe that looks pretty good. Okay, so now we need to extrude cut this throughout the part. We'll just go through all, kind of lazy, so there we go. And now we need to do it again by going the other direction. So we'll draw it like this. What's neat is now we can, since we already have this first cut done, we can actually project these faces like so, and it'll create these reference lines that make it a lot easier to draw. So we'll grab this, we'll grab that, we'll pull it over, dimension here to here, and we'll do 3.8 deep, solid, extrude, cut, ISO through all, and done with that. Oh, I did forget, there's actually a radius on this corner. It's not a sharp corner, so let's roll back the feature tree a little bit and slap a little radius on there. 3 millimeters, just a guess. It looks fine, why not? And then we'll go ahead and bring those grooves back. Next, these are chamfered on the ends, these little tines here. So let's go ahead, we're gonna hit a chamfer. Hit those corners like this. First dimension is going that way, so this way, So we'll go ahead and describe that as 3 millimeters. And the second dimension is 5 millimeters. And there we go. Just like that. So that looks pretty good. I don't like that, there's a lip here for 3D printing because we're going to be printing it in basically this orientation. So, but we'll see how it goes. So I'm going to save this. It's a screen door corner. Save. All right. So next what we need to do is actually make this into a 3D part, right? So to do that, we use Prusa Slicer, and I'm going to export this. So now that it's saved, I'll make it. I don't want to send it to Mexmesh here, but let's preview that mesh and see what a mesh looks like. See, pretty simple, pretty straightforward, not bad at all. So let's go ahead and send that out. I'm gonna just kind of drop this in models. Let me see here, tools, and we're gonna call it screen door corner. Save. All right. Next we go into Prusa Slicer. We're going to add the file we just created. So models, tools, screen door corner. Load it up. Looking pretty good. Looking nice. I like it. And for this, we're going to just do normal print, PLA, and we're going to use my big blue printer. And supports everywhere, infill. So for this, I don't think infill's all that important. What I think is more important is the number of perimeters. So we're going to bump that up to 5 to make it extra strong. So let's go ahead and slice it. Take a look at what we did. Yeah, see, it's not gonna want us to print that because this is here. So what we can do is actually drop the model by 0.5. I think that's what we had, so let's do 0.5 down. And then we'll slice it again. Actually, let's just go into Fusion and do that. So because we don't want to print support material underneath this, I mean, it's only like 0.5 millimeter, so it won't print correctly. We're actually going to cut the bottom face out. It's kind of cheating, but I'm okay with it for now. So we'll extrude this, we'll cut, and we will go not distance, but to object, that object, and just remove that full base like that. Now it's nice and flat, it'll print nice and easy. So save the file, tools, make, select, okay, screen door corner, save, yes. All right, next thing we do, go back to Prusa Slicer, and we're gonna delete that model and re-add it now that it has no bottom. There we go. And slice. We can preview the 3D print. This support material might be a little bit tough to move, but we're going to remove, but we're going to try it out anyways. And let me just show you what the inside looks like. Pretty hollow, but that's okay because I don't think it really needs to be much more than that, especially for the first time we try to print it. So let's export the G code. Models, tools, save. Exporting finished. Next we go over to our 3D printer. We're going to preheat it. We're going to upload the code that we just cut. Saving. There it is. So we're going to load it in. And now we got to wait for it to heat up. All right, the printer's all heated up. As you can see here in my little, graph, we're good to go. Actual temperatures, 210, 60 degrees centigrade. We're gonna go ahead and hit print. Here we go. go ahead and clear that little bit of filament from there, and starting its homing procedure now. And there's the plastic purge extrude. And away we go. All right, so the print just finished. Check it out. Let's get the broken one sitting next to this. There we go. Look at that. Peel it off. Very nice. Very nice. Now I'll have to remove the support material. So the support material printed between that slot, and that can sometimes be a pain to remove. I'm actually a little concerned I might not be able to remove it. Luckily we have tweezers. So let me see here. Just gotta be careful. There we go, nice and easy. And there it comes, just like that. Now I gotta do the other side. Boom. And there you have it. Brand new. Okay, so I hope you enjoyed that video. As you can see, we were successful in making a new part. Took about 45 minutes to print and cost about 20 cents in material. And the modeling only really took us, 15, 20 minutes at most. So I'm pretty pleased with that. Yeah, if you liked what you saw here, like, subscribe, share, that always helps. If you have any comments for what you'd like to see me do next, I would gladly model some more stuff around my house, or maybe we can make some different content, change the format. Thanks for stopping by.